We will start now. Okay. Smoothly, but. Okay. Good morning, everyone. So we will start this session on rethinking cities to improve energy sustainability. We are a bit late, but we are trying to catch up on the time schedule from the delay of this morning session. Well, if we are to reduce emissions coming from heating, cooling, and power necessary to run our homes, we will need to rethink buildings and cities and urban communities as well. And the way we are producing, storing, and distributing the energy has to be rethought. And as in this morning session was mentioned, we have to certainly tackle the issues we are facing now. This session will look into the new and different ways of approaching these issues, using different energy resources, technologies, and data. So we have 5 speakers from academia, from administration, so from cities. We have consultants as well, and we have private companies giving the visions on how these issues can be tackled. So we will start with Giovanni Vicentini. Giovanni is an expert in GIS analysis. Giovanni works at as a freelance consultant, mainly for the province of Torino, in the Covenant of Measures framework. As such, he has been elaborating energy and emissions balances and the setup of an energy management system for local authorities. We talked about methodology based on GIS tools for implementing and boosting energy efficiency and RES development in cities. Giovanni?
Probably this one, okay. So thank you very much for the invitation. I'm a consultant. I work mainly in the Covenant of Major framework, as she told me. And we are working mainly with municipalities. So we are trying in this methodology that I am presenting you to find out the best solution to boost RES, so renewable energy sources, and to boost also energy efficiency in residential buildings at the local level, so at the municipal level. We have a lot of municipalities in our province, and very different one from the other. We have the biggest city of the province is the city of Turin, but we have also very small municipalities. So we have to find out different solution for each kind of municipality. And with this work, we are trying to find out how to find the best solution and how to incentive the citizen to renovate their building. So this is the logical framework of my presentation. We started all these 3 pillars. We made a lot of analysis with GIS tools, so IT tools, and we started with the estimation of energy demand at the building level. So for each building of the municipality, we analyzed a lot of data, and we tried to estimate the energy demand, both the electrical energy demand and the thermal energy demand. And after that, we tried to evaluate also the renovation potential, so the inclination of citizens living in those buildings to renovate their building, mainly from considering some socio-economical variables, and not just the building variable, but also socio-economical variables. In the end, we tried to estimate and to find out the RES potential. So for each building, how much we can install, mainly for the solar renewable and also for biomass renewable. Regarding the first pillar, so we tried to find out with a top-down approach, in this case, the space heating and the thermal energy demand and the electric demand. The first slide I'm presenting you, it's about the thermal energy demand. So we captured a lot of data coming from different sources. In particular, we used the energy data for thermal uses that we had from the SEAP, so the Sustainable Energy Action Plan. We had this data for all the building sector, for residential sector, but just for all the municipality, and we tried to split this total value for all the buildings, so to understand for each building how much does that building is consuming. But we used also some data coming from the GIS software. So, for example, the heated volumes, for example, the period, the construction period of each building, or the form factor. It was calculated within the GIS software. But we used also, for example, some other data coming from the LIDAR analysis. So, for example, the height of each building, or from other analysis of the imagery, for example. And we used also, as you can see on the left, some data coming from the environmental agency, for example, some climatic data that are very important in the estimation of thermal energy demand of the residential buildings. Putting together all this data, we try to find out some curves that you can see on the right and find out some algorithm that we can apply to in the GIS tool to all the residential buildings. So we have some data of the building, but we want to try to estimate the thermal energy demand. So we applied for each building the curves on the right. And you can see the results here on the top of the slide. You can see the difference between the Torino city, the bigger city in our province, 1 million inhabitants, and a smaller city, for example, here Pianezza, it is 10,000 inhabitants. You can see that the application of the curves to the buildings, to each building, we have very different results. For example, you can see that the best situation, you can find the best situation on the left in the Torino city, in the bigger city, mainly for the form factor, because if you have some big buildings, some condominiums, we have a lower form factor, so we have a lower energy demand. On the right side, we have a smaller municipality. We have a lot of single-family houses. And here we have the worst situation because we have a higher form factor in this case, for example. But also the construction period is influencing the energy demand in this case. So we have estimated for each building the energy demand. Probably in the future we will try to integrate this estimation, top-down estimation with some other data coming from the bottom up, so from the citizen directly, for example, from the bills. But it's very hard to work at this level, at building level, for all the province using this data. On the right, you can see that we have also estimated the electric demand of each building, mainly starting from the estimation of the number of inhabitants for each building. We used some data from the census, from the National Statistical Agency, but we used also some other data from the statistic of the per capita electric consumption. So we have applied the per capita electric consumption with the estimation of inhabitants for each building, and we have calculated the electric demand. This was the first pillar, the first step. The second step was the estimation of the renovation, the inclination of citizens in renovating their building. And we focused our analysis in the socioeconomical variables. So we used some socioeconomical variables coming from some statistical investigation, mainly for the census. And we used some factor, as you can see, the age factor, so how much the population is, if they are young or old people, the education factor, the employment factor, the ownership factor, if they are owner or tenant, and the building factor as well. And these socioeconomical variables are very useful because here you can see really if the people living inside this building, that building has an high inclination on renovate their building or a low inclination. For example, if I'm an owner of a building, I have an higher inclination to renovate my building because it's my apartment, my flat. If I'm a tenant, I have a lower inclination. If I'm young or I have a high degree level, for example, I have a higher awareness about the economic impact of my energy uses. And for example, other things, for example, if I'm young or I'm working and I'm not unemployed, I have a higher credit access. So all these factors are very important to estimate the inclination of citizens in renovate their buildings. And we have analyzed also this factor with the GIS tools, so at a territorial level, with the georeferencing these factors. As you can see here, also in the application of these factors to the reality, to the territory, you can see that each building, we have on the left the estimation of energy demand. On the right, we have our objectives. How much we can boost energy efficiency for each municipality. For example, in the bigger city, Torino, so where we have a lot of condominiums, multi-family houses, we have, as you can see on the right, a lower feasibility factor. So we have less families that can renovate their building, or they can renovate the building, but less deeply than on the other municipalities on the right, for example, in the image. They are very small municipalities with a lot of single-family houses, and they have an higher renovation rate because they are mainly they have a shorter decision process. For example, they don't have to share the process with other tenants in the building. They have a higher, for example, economic availability or a higher credit access. Okay, we used here also some location factor because a building located in a district heating area, for example, have some limits because you cannot change, for example, the boiler. Or if you have the building in the historical center, you have also some limits because you cannot renovate your facade. You have some limits. You have some. The law is limiting your action. So we have to consider in the renovation feasibility also the location factor. It's very important. The first step and the last step was the estimation of the renewables. So the application of renewables on residential buildings. So we have produced some solar maps, for example, as you can see on the right, using some 3D models, both considering the terrain model, but also the 3D model of the buildings, and considering also the 3D model of the rooftop. So we have estimated how is the potential of, for example, solar renewable in the south exposure rooftops or in the north. And we have estimated how much each building can produce of electricity with PV plants or thermal energy with solar thermal plants for each building. So now we can compare the energy demand and the energy supply from renewables. And we can adapt the local building code to boost in a correct way and in different way for each municipality renewables. Here you have an example of our solar map applied to residential buildings. In the end, for example, regarding renewables, you can see that we have compared some municipalities in our territory, and the province, the city of Turin, so the bigger city with the bigger buildings, has a very low percentage of electric or thermal consumption that can be satisfied with RES, because we have a lot of big buildings, so we have a lot of big energy demand, but we have a small, for example, rooftops, so we cannot install too much of solar sources at the top of that building. So we have the best results in the small municipalities and the worst result in the bigger municipalities. So the conclusion, we think that to develop a smart city, we need smart policies developed by local administration, but we need also smart citizens. So we have to train the citizen to behave in a correct way and to use technologies in a correct way and to try to find out the best solution for them, because they are very different, the solution. And we need, obviously, some ICT instruments. In this case, we used the GIS tools that are very powerful. We need some reliable and updated data, mainly open data. This is very popular now, but we need also data georeferenced, so applied to the reality, applied to the territory. And we need to find out all the solutions, because we have to find in each time the best solution for each municipality and for each citizen, for each building. Okay. Here I have some conclusions. So as you can see, the open data are a very powerful instrument, but the availability is now it's very low. We have the goodness of that data is infrequent. We must intercept also some data coming from the city, directly from the citizen, using smartphone, using some sensors. So we have to integrate the bottom-up approach with the top-down approach to have more data to analyze and to provide to the citizen, to the municipalities, more instruments, more instruments, yeah, to find out the best policies. I have finished. Okay.
Thank you very much. Thank you very much for the for the speech. We'll have the question and answer sessions at the end of the session. So now we will give the floor to the next speaker, Jonathan Brooks from Bristol City Council. Jonathan, as he's project manager within the City Innovation Team, is responsible of coordinating projects within the Smart City Bristol program. He's currently involved in smart metering and smart data projects in collaboration with the other European cities, local businesses, charities, and energy providers. He will talk about the STEP project, a system thinking for energy efficient energy planning. So, Jonathan, the floor is yours.
Good afternoon, everyone. I hope you can hear me okay at the back there. As Manel said, my name's John Brooks. Just trying to find my presentation here. Okay. So yeah, good afternoon, everyone. My name's John Brooks. I'm here to speak on behalf of Bristol. And Bristol, if you haven't been, is a city in the southwest of England. Here are a few things that we're famous for. It's a fantastic city. We've got a very mature smart cities profile. And what I'm going to talk to you today is just one of the many projects we're involved in as part of the City Innovation Team. It's called STEEP, and STEEP stands for Systems Thinking in Energy Efficiency Planning. And any of you that have been involved in projects with the Commission will know that you've got to have an acronym. So that was ours, and we had to call it something. So what I'm going to do is I'm going to go through the dual aspect of the methodology which we've applied in the project. There's two main aspects to it. There's the systems thinking element, which I'm going to talk a little bit about, but there's also what we're calling an open source or open data collaboration platform, which we've developed in collaboration with one of the partners. So just a little bit about the project to start off with. STEEP is funded under the Commission's FP7 programme. There's 3 cities involved in the collaboration. There's Bristol, Florence and San Sebastian in Spain. And the purpose of the project is to try and implement or test out how useful the systems thinking approach is to energy master planning. And what we aim to do is test out the methodology on a small district in each of the 3 cities. And if it was successful, or if we could scale it up, we then apply it to the entire city in general. So, as I said, it's a problem structuring method. It's about a year old now, the project, and it applies 2 main aspects of a particular methodology. The first is the systems thinking approach, and the second is the collaboration platform. So to start off with, the systems thinking, what is systems thinking and why should we use it? Well, we found that in Bristol, despite our significant and mature level of technical expertise in the area of energy efficiency, despite the level of goodwill and support we had from our politicians and from local businesses, our energy consumption wasn't going down in the way we'd anticipated. And that's because we conceive of energy master planning as what we call a sticky or messy problem. And as it says here, the problem situation, which for us was to reduce our carbon footprint as much as we possibly could, that involved getting the support and buy-in of various different stakeholders and lots of different interested parties and different, with differing perspectives. The problem situation itself is not well defined. And what I mean by that is stakeholders, citizens themselves are not always clear what we're trying to achieve in terms of our high-level objectives. The success of our interventions, whether that be technical interventions or behavioural interventions, there wasn't universal consensus about what we were trying to achieve in our particular area. And also the data that supported carbon reduction targets or energy efficiency targets wasn't always reliable. Also, the final point here, what I've put is as unconscious rivalries. What we found is that in the UK especially, we have a very complex mixed market in terms of our stakeholders. Our regional and local government isn't as sophisticated or doesn't have the extent of the devolved powers as it does in other countries. So we're reliant on a lot of private sector organisations to buy into our particular vision and to sign up to our particular goals. Now, consciously or subconsciously, they're driven by a number of motivations which are different to that of the local authority. So, systems thinking, what is it and how do we do it? Well, in Bristol, for our particular approach to systems thinking, we tried to identify and engage key stakeholders in structured workshops where they could give us feedback regarding the performance of our overall objective. For Bristol, we were trying to develop a zero carbon zone around our what we call our Temple Meads Enterprise Zone, which is the area around our main train station. So what we did was we targeted, and this was the key bit, we targeted and identified key stakeholders that we wanted to get into a room to discuss which parts of that particular objective were not functioning very well. And how we did that was the University of Bristol conducted a number of modelling sessions whereby individuals broke down a particular problem into its component processes, and then they gave that a particular rating. And we called it the Italian flag rating, as you'll see in a minute, because what it involved was you rate the performance of a particular process. You give it a green, white or red rating depending on how well it's performing. So what happens within these particular sessions is you take your overall objective, as I said for Bristol, that was a zero carbon enterprise zone, and you break it down into its particular component parts. You then map the dependencies between the different parts. And by doing that and by involving the stakeholders directly, you get an overall picture of where the barriers and issues might be to achieving that overall objective. So, for example, this is an example of the process modeling. This is an illustrative model, but as you can see at the top there, you've got your high-level objective that you're trying to achieve. You break that down into all the other things that have to happen to be able to achieve that particular objective, and then you color-code it depending on how well you think it's performing. You can see here that at the top, you've got a big block of green and a big block of red. That means that you know that particular process is performing quite well, but there's still some area for improvement. This is a little bit more detail about how you define how well a process is performing. Evidence that it's successful means you increase the amount of green that you give a process. If there's no evidence whatsoever, or you haven't got a clue how well you're performing in that area, you give it a block of white. But if you know you're not doing particularly well, you give it a block of red. Now, you might ask, that's just common sense. You might say, it's pretty obvious that you have to break down a problem into its component parts. But what this structuring method allows you to do is focus attention on those areas where there's a big block of red and you know that you're performing badly. It also then allows you to explore what the issues and barriers are to improving that particular performance. And crucially, this is not a one-off snapshot process. You use the stakeholders, you continually engage with them over the course of a project, and you continually revisit the model and you reevaluate and reassess how well you're performing. So, in a nutshell, that was the systems thinking element of the project. The other element of the project is what we call an open source collaboration platform. We're very conscious, and the Commission is very conscious, of being able to share expertise in what we call an open source way. That means sharing our understanding and our expertise with other municipalities and cities. So what we've done, and this is in collaboration with one of our partners, Centre for Sustainable Energy, we've developed a wiki-style collaboration platform. There's few key points to emphasize here, that it uses the wiki-style format. It allows co-editing and people to change the content and the data that's stored on there. It's not so much a single platform as a number of platforms, as a product, which we can give to people, give to organizations, and they can use it in whatever manner they want. And it's basically a space for people to collaborate and discuss interventions around energy efficiency, but also other things, anything they wish. That's what it looks like. The prototype is almost ready for deployment. It's going to be available at the end of December this year. So if anyone's interested in how it functions, what the functionality of it, then obviously get in contact with me. But that's what it looks like at the moment. You can see the standard wiki format. And this is what it does. So it's a prototype web application for creating and collaboratively editing accessible documents. In addition to that, though, it allows creation and sharing of material required for energy planning. So there's a GIS capability on the platform itself, which means that if you have a data set that you're interested in mapping, you can put that on there. And what that does is it gives you a visualization of the complex energy flows within a given area. It also allows for problem structuring methods and the breakdown of the different processes, as I've described, but on the platform itself. And as I say, it's available in 2015. So in summary, STEEP, has a two-part innovative approach to energy master planning. It's got the systems thinking aspect, which assumes that problems are complex and not always solved by technical interventions, that there are behavioral and organizational changes that also have to happen. It's a facilitated discussion forum for people to discuss what those barriers are and identify areas of underperformance. And once you've done all that, what we've got is a product that organizations can take away and use to collaborate on developing solutions and mapping data in a visual way. I'd encourage you all to visit our website, smartsteep.eu. That gives you a very high-level breakdown via webinars of what exactly we mean by systems thinking. So if you're slightly confused or befuddled by what I've tried to describe as systems thinking during this presentation, don't worry. The University of Bristol have actually produced webinars which you can download and access yourself. And as I say, the wiki page, the stakeholder platform, if you want to go and take a look, then it'll be ready for deployment at the end of next month. Otherwise, thanks very much. Thank you for listening.
Thank you very much, John. So yeah, we'll give the floor to the next speaker, who will give us a broader approach on energy planning. So John Dulac from the International Energy Agency. John is an energy analyst in the Energy Technology Policy Division at the IEA. John's expertise is in urban planning and development policy with an emphasis on transport and building technologies. He's leading the Energy Technology Policy Initiative on urban energy systems analysis, and here we talked about energy technology perspective 2050 in support of low carbon sustainable development in cities. So, John.
Thanks. Thanks very much for having me. I work for the International Energy Agency in our Energy Technology and Policy Division. Our division is responsible for looking at the technology policy options to meeting low carbon energy efficiency targets to 2050, which I probably should mention as a first caveat is at a global scale. I've tried to put this into context today that will be most valuable to local decision makers and energy planning policy makers. Just to give you a brief background of where we stand today, this is the global energy sector in 2011. I think the most important thing coming out of this, which is here on the bottom, does this have a laser pointer? So this right here is that a quarter of all of the primary energy that goes into the global energy system is lost every single year. This has been constant for the last 20 years or so. So just think about this in terms of how an economist would see it. For every 100 euros you invest, 25 of them are thrown out the window. It's not an efficient system, and typically we see this as being the way things stand, but we know we can do better. Now, I point this out for a specific reason, because as you can see here, the bulk of the energy is going to these three final end-use sectors once transformation and electricity are produced. And the important thing here for city makers is that the last two categories, buildings and transport, are clearly the largest energy demanders in the end-use sectors, and most of it does happen in cities. In fact, the IEA did a report in 2008 estimating the amount of energy that was consumed in cities. It's about 3/4 of global energy demand on a final consumption level. So it's important, and cities clearly play a role in meeting our energy efficiency and climate targets to 2050. Now, having said that, to also give you an idea of the importance on a global scale of buildings and transport, and again, this is at from a global perspective and not an urban scale. This would certainly change if we were looking at cities. Buildings and transport account each for about a third of final energy demand, which means that they're about 1/3 of primary energy demand in the global energy system. And about 50% of electricity produced in the power sector, so this wedge here, actually goes to buildings. So if you were to reallocate this, buildings and transport become by far the most important end-use sectors in terms of energy demand. And in terms of emissions, they're about 1/4 of global emissions. Again, if we had to reattribute electricity to the building sector, this number would go up significantly. Now, I take this example and give you one last slide from a global level looking at buildings energy use to pair back these last two slides to the importance of buildings and transport in cities in meeting energy efficiency and climate targets. Now, as an example, buildings' energy consumption is largely driven by heat, which is essentially space heating and water heating. If we add in space cooling, which is an increasingly growing demand, especially in warmer climates and emerging economies, it's about 55% of energy used in the building sector. Now, I say this is important because I just mentioned in the first slide that about 40% of energy is lost from primary to final because the global production of electricity is only about 40% efficient. So about 60% of energy that goes into electricity production gets lost as heat. So one has to ask the question of, if 55% of energy demand in buildings is one form of heat, either heating or cooling, and 60% of electricity production goes out the window as heat, are we not pairing these two well? There are certainly lots of other mentions, but I thought this was an interesting point, since in cities, especially in OECD countries, heat is the primary driver of energy demand, both in the building sector and from a broad energy perspective across the different end uses. So, as I mentioned, my division is responsible for Energy Technology Perspectives, which is now an annual publication that the IEA does, looking at the three scenarios, essentially, for the global energy sector. The first being our 6 degrees Celsius scenario, or business as usual scenario, essentially where we think we're headed if the world does not make major improvements in terms of energy efficiency and energy demand reduction. The second, which is not here, would be our 4 degrees Celsius scenario, which across the different end-use sectors essentially means meeting expected policies. So, for example, in the transport sector, announced global fuel economy policies. These may or may not be likely, but actually, if we're looking at this wedge, they don't make much of a difference. The real difference is this bottom piece here, our 2 degrees Celsius scenario, or 2DS, which is in line with the UNFCCC's goals of meeting 2 degrees Celsius by 2050. So, in other words, 450 parts of carbon per million in the atmosphere. And as you can see here, there's a significant wedge that is coming from savings in power generation, essentially decarbonizing the power sector. But there also, if we had to take the next two biggest wedge, it's coming from buildings and transport. And again, as the majority, as of 2010, of the global population now lives in cities, and this will increase to about 65% of global population by 2050, buildings and transport in cities will be the significant drivers of these savings. Now, at the IEA, we have, since 2012, been promoting an energy systems perspective, and for very good reason. For the last 50 years, essentially, of energy planning and energy efficiency measures, we've treated both power generation and the end-use sectors as silos in the energy system. In other words, we pursue energy efficiency measures in electricity production, we pursue building envelope improvements in the building sector, we pursue fuel economy perspectives in the transport sector, but we're not looking at how these interact with each other. And as the world increasingly becomes complex with renewables integration, with smart grids, with increasing demand from the end-use sectors, with the creation of what we're calling prosumers who consume and produce energy, we need to start thinking about how all of these interact with each other, and more importantly, how these interactions help to create a much more sustainable energy system. Now, as a tool, I guess, I've prepared 3 slides here, since I know a lot of you are interested in what cities can do on a local scale. So looking essentially at the different end-use sectors, starting first with buildings, we've produced 3 publications, 2 of which are pictured here in the last 2 years. The first and foremost is the one here on the bottom, our Transition to Sustainable Buildings book. That's a highly comprehensive technology policy publication looking at all the end-use sectors across the different building types, so essentially commercial and services, what these mean in terms of global potential, in terms of reducing energy and emissions in the building sector. Now, this is actually going to be available for free starting in January. It's still for charge, but in January you can download this for free. The second and the third that's not pictured here are our technology roadmap on building envelopes, and likewise a policy pathway on building envelopes, essentially putting in place the policy frameworks and the technology options for reducing, more or less, as I mentioned before, the primary drivers of energy in the building sector, so heating, which is by and large done through improving building envelopes, so improving windows, roofs, walls, building codes across the different countries to put in place the policies to support these changes. And these are available for free on our website, as are all our other technology roadmaps and policy pathways. In the transport sector, before I go to the transport sector, another piece coming back to this heat and systems integration is a report that we released in June of this year, looking at how we link electricity and heat systems. This is actually a compendium of 6 case studies looking at industrial CHP, or cogeneration applications, and district heating and cooling applications, where in all 6 case studies, the message coming across is that they have applied this through a policy and business framework that is forward-thinking, that is putting in place the right policies and financial tools and market instruments to allow local players to actually achieve these efficiency gains. And what is most impressive, especially in the DHC, so the district heating and cooling applications, is that they have achieved efficiencies that are above 100%. So for example, in Marstal, Denmark, they have built a new district heating network that is using solar thermal. It's also using biomass in replacing traditional diesel production for heat. It also has done this through low temperature distribution, integration with the Danish wind market, so essentially variable renewables, and then finally pairing this with energy efficiency measures in consumer homes to reduce the amount of energy they demand to achieve efficiencies that are well above 130%. And from a technical perspective, what's quite interesting here is that the coefficient of performance, so essentially the efficiency rating, in the daily variations of production can go over 20, which in layman's terms essentially means that they're achieving efficiencies above 2,000%. So for every unit of energy they consume, they are producing 200 more units of usable energy for the building stock. So this is really impressive, and it's clearly the direction we need to go in terms of thinking about how to meet energy demand in an integrated and flexible way. And sorry to mention, this is also for free on the IEA's webpage. And the last, coming to the transport sector, which as a transport person myself is probably the most difficult to address, is again a compendium of case studies in our policy pathway on energy efficiency and urban transport that looks at more or less 50 cities across the globe and what they're doing to identify transport needs and issues, how they're going about planning and implementing these measures, what they're seeing in terms of results, and what this means in terms of the potential for transport in cities moving forward. I think if anything is to be taken from the message of this report, it's that this plan, implement, monitor, and evaluate process is extremely valuable. In all of the cities that have been studied in this report, they have gone about this in a holistic way of not just assessing what the issue is in the city, but what are the different policy options to meeting that demand and energy efficiency measures, and then really going about making sure to track the progress in those fields to ensure that the projects are successful. Again, this is also available on the IEA's webpage for free. So I think if I had to have two messages from a global scale from the IEA perspective moving forward in energy efficiency in cities is first, we shouldn't underestimate the value of thinking within the box. Very often we think about thinking outside of the box and coming up with new plans and new technologies and new measures, but the reality is across the final end use sectors, especially buildings and transport, the bulk of technology and policy options are already out there. And thinking within the box and understanding what these can do in terms of simple measures of reducing energy demand and improving energy efficiency is critical. The second is, as has been seen across these three reports that I mentioned to you, that we need to do a better job of sharing best practice and lessons learned across the different energy sectors, and especially in terms of communication between cities. Very often these get lost in policy dialogues at the national level, and what happens is that local policymakers find themselves in the situation of not knowing which measures to pursue or how to finance them or what technology options exist. And I think what comes across in these case studies is the work is already happening. We need to do a better job of communicating it. And I think this is certainly the right platform for it, and I'm very happy to be able to share this with you, and certainly very keen to hear your experiences as well. Thank you.
Thank you very much, John. So, from this broader view of the energy issues for cities development, we are going now for a more specific topic. The next speaker is Massimo Bertoncini. Massimo is Director of Urban R&D Projects at Ingegneria Informatica. Massimo is shaping the company vision on smart energy systems. He has been serving European Commission DG Connect, Smart Cities and Sustainability as a scientific expert, and he's author of several international publications. He will talk about energy storage for a multi-network optimization at district level. Massimo?
Thanks for giving me the floor. And my name is Massimo Bertoncini, and I'm the director of the European R&D projects on behalf of Engineering Ingegneria Informatica, which is currently the largest ICT service and technology provider in Italy, with a very extensive coverage of all the main domains in which cities, innovative cities are truly engaged along these days. You can see that we are headquartered in Roma, but we have many different premises scattered between Italy, Belgium, Ireland, and above all, São Paulo de Brazil. And what is important to say is that we are a comprehensive offer in terms of market offer. And in terms of main customers, you can see a snapshot of our major corporate offer, which include markets ranging from local authorities or from energy utilities, healthcare, and telco, and so on. So let's try to introduce the outline of my presentation, which will try just to give a look on this concrete experience on the INGRID project. Differently from the other speakers, which try to shape the vision in terms of energy thinking and energy planning of the city, this speech is mostly focused on the operation, so how to optimize operation when you have different energy carriers. And this is even a perspective for one company, like the company which I represent, which is deeply engaged and deeply active in a lot of European projects. So we are nurturing innovation based on the participation of the European projects just towards concrete, turning on concrete innovation for cities, authorities, or for others, energy stakeholders which are interested. In that respect, INGRID is a European R&D ongoing project which aims at demonstrating both technical and economical feasibility for a decentralized solid hydrogen energy storage, which aims to support the joint optimized operation of a multi-network energy distribution systems, which in that case will include simultaneous management of electricity and hydrogen infrastructure. So coming back to what John said before, I particularly appreciate the points pointing out just to the linking energy system. So this is our project, and our concrete implementation is going exactly in that direction. That is to say, to link different energy infrastructure in order to achieve larger system level efficiency. What is the basic, the background and the motivation for having this INGRID project? It is something which is really occurring in our life, in our cities and surroundings. That is to say, the social commitment is just to move forward towards a larger penetration, larger sharing of fluctuating renewable energy source, which should be integrated as much as possible in the current energy networks, in the current electricity networks. So despite this system was not originating in a specific smart city domain, however, the concrete test case which I'm going to illustrate you is strictly focused on matching a smart city, a smart district energy requirement domains, which goes in the direction of alleviating even the energy problems of the energy demands of the cities. So just a couple of slides for illustrating what is the current trends for energy systems. You can see decentralization of energy management and power production versus integration of energy carriers. You can see very quickly what is the background, and our basic motivation for INGRID was just that very often you can see that this rising share of intermittent power generation, like PV farms or wind farms, are often situated in areas which are very weak from the perspective of the connection. So in the rural areas, typically power electricity networks are weaker. Due to the not larger end user backbone. And in that respect, we have this distributed energy generation, which is more and more decentralized, closer to the consumption point, and we are facing even with temporary network overloading, resulting in a forced shutdown of the generating facilities. So what in technical jargon is called rest curtailing, which are preventing just the optimal exploitation of the societal investment in terms of construction of these plants which have been already done. In that respect, what is the reason why we think that this hydrogen energy storage will be beneficial? The main reason is that usually hydrogen energy storage could be considered as a major source for providing a larger flexibility to the electricity network, and it could be even considered as ideally coupled in terms of the optimal multi-system operation in order to achieve this larger system level efficiency. This is the background which all of you probably know in terms of the discrepancy between wind or solar or rest power and the grid load. So you can see that these gaps are originating problems in all the networks. And just going very quickly, the approach which we are going to use is something which is based on the decentralization and smart decentralized self-sustainable energy system. So our approach is something which is aligned with the paradigm shift which is occurring in the structure of the future energy systems, in which you can see a lot of rising prosumers. Energy management is becoming more decentralized, and even energy carriers tend to become more integrated on local level. So what we can do, I just go immediately to the in-grid concept, is as you can see from the figures, we are going to have water electrolyzed. So you can see, a water electrolyzer, WE, which is going just to work as a load when you have a surplus of electricity which is not poised to be consumed locally, so which is creating problem for balancing demand and supply. The surplus of hydrogen generated from the water electrolysis is put within this HSS, hydrogen solid storage systems, which in a safe way is going just to conserve, to save these hydrogens. And finally, we have two different lines for usage of this hydrogen, either in what we call the closed loop. This is a kind of the quasi-adiabatic transformation, in which within the 6 hours of hydrogen generation, you can have a usage of the fuel cell and using the surplus of electricity for regulating low voltage branch of the network. Either you can have open loop, through which the surplus of hydrogen will be freely transported to closer final end users through the hydrogen's merchant. Having said that, we have been testing two different optimized and management policies. One is exclusive support of the power distributors, and the second one, whose we are really appreciating just the value, is just the support, the different value proposition in which we are going to support the multi-service utility optimized and operation. In that case, the objective of our monitoring real-time and control will be how to instantly allocate the best amount of the different energy carrier, either electricity or either hydrogen, in order just to finally, in order to have this systemic level energy efficiency. This is the background in our test sites. You can see that we have an active reverse power which accounts for the 60% in average at the primary subsection in our demo sites. And here you can see what are our demonstration settings. So in-grid system is connected to the medium voltage branch of the power network in this very nice Troia located in Puglia region in southern Italy, where there is a significant intermittent generation from PV and wind farms where will be converging. We have this problem of this overload of the power which is available and not being used in a very close point. So either you will be able to transport through the high voltage, either you have to store thanks to our systems. So just a snapshot of our demonstration, which is currently under construction. You can see in green a snapshot of our PV farms. In red, you can see the primary substation provided by Enel distribution system operator. In blue, you can see the place in which our plant will be currently has been under construction, and this is even the system layout. What in the previous slide was colored in blue, you can see here in in major details. What is important to say is that for the time being, we are even just to try to have to develop models, concrete sustainability models, because you know that the major problem for the storage systems supporting even decentralized energy demand from a smart city is high capex cost. So what we develop is a sustainability model which is taking into consideration of different situations, different ownership, different location. And in our case, we developed as a business model which is able to operate the Ingrid plant through a local third-party independent service operator within a merchant ownership model, in which you can envisage different storage services dealing with together deploying in a regulated market services just to the local district, to the local smart city utility, and even provide service for smart city energy management in a deregulated market at the crossroads between the electricity and hydrogen value chain. Let's consider that this district, this Troia small countries accounts about 10,000 inhabitants, and so our storage is about 1.1 gigawatt hours in terms of the decentralized storage capability. So what we are investigating is different revenue sources based on even stacking software storage services, and in that respect we are just in the phase of validating even from the economic perspective our results. For the time being, while the plant is under construction, one moment I'm just going to the conclusion, we have been understanding what are the dynamics of the business models. It seems that there are some promising results concerning just the potentiality for offering altogether this kind of services and bundled in a stacked way. This is the only way for smoothing just the high capex for storage system. And finally, what I would like just to say is that in this case, this is even an efficient way for producing green hydrogen, so CO2 neutral, because the process is completely green from that perspective, even taking into consideration the possibility for interlinking this energy of energy system. So thanks for your attention, and I will be happy to answer your question.
Thank you very much, Massimo. So we'll go to the last presentation done by Leandro Madrazo from La Salle University. He's professor at the School at Architecture La Salle and director of research ARC Group. Leandro researches on application of ICTs to architectural design and construction and energy efficiency in buildings and cities. He's participating in the FP7 project for optimized energy use in cities, and that's the topic of his presentation. Integrated platform of data and tools for energy assessment for urban areas and cities.
Okay, thank you. Good afternoon. I'm happy to present here the final results of this 3-year project we have been working on under the FP7. Also, it's a project that is related to energy efficiency of urban areas using semantic technologies. So it has been a 3-year work. Maybe like this. Vale, gracias. Sorry, let's start again. So this is the consortium of the project. We are the coordinators and also the responsible for the development of the integrated platform. There are 9 partners, and there are research groups, there are energy consultants, there are also groups who are working also at the global level and at the local level with cities in energy consultancy and efficiency. The purpose of the Semanco project is to provide tools that different stakeholders involved in urban planning, architects, engineers, building managers, consultants, can use to make informed decisions about energy planning to get energy efficiency urban areas. There are 3 cities who have been participating in the project: Manresa, which is near to Barcelona, Newcastle in the UK, and Copenhagen. This was the diagram we used to present the project 4 years ago, and just to present our concept. It's a diagram that could be used for any other almost smart city project. We started with the assumption that there's data that is important to take decisions about urban energy efficiency in cities. Data which could be in different repositories of different domains, generated by different applications. On the other end, we have possible stakeholders who need this data in order to take decisions in their own fields with the objective of reducing carbon emissions. So in order to get this data to the level that these stakeholders need, there is a gap in the middle. And this gap is the one we try to fill with these semantic technologies, with the semantic energy information framework, which is one of the major outcomes of this project. And this is a nexus between the distributed data and the applications that the different stakeholders use in the domains. So just before showing you the results of the project, which is the Semanco integrated platform, just a few concepts just to create the context of our work. Just from the most obvious, cities are complex systems. Systems in both sense, in the physical sense and in the conceptual sense. There are systems physically because there are different building structures, infrastructures, and there are also activities that take place within these built environments, taking place by different agents, actors, to fulfill certain purposes. The problem of carbon emission in particular is a systemic problem. It cannot be reduced to any domain or to any geographic scale. It needs a systemic approach. Urban energy systems, which is our reference concept in this project, has been defined by Kierstead and Shah as a combined process of acquiring and using energy to satisfy the demands of a given urban area. But understanding the city as a system or an energy system is not enough. We have to create models to understand how the systems work. Models are also representations of the physical structure, but also of the activities that take place within those systems. In particular, an energy system model has been defined also by the same authors as a formal system that represents the combined processes of acquiring and using energy. Within this context, the goal of Semanco has been to create models of urban energy systems with 2 purposes: to understand the current state of a system in a particular urban area, and to help to take decisions to influence its future evolution. So models of urban energy systems rely on data. This is, as everybody knows, a key issue in every application of smart cities. Data which is necessary to reproduce the activity of the system and also the static values of the city. Data that is static and dynamic, if you want to see it like this. But energy-related data is dispersed in different databases. It's diverse because it's generated in different domains and by different applications. It's dynamic, it's changing constantly. So semantic technologies in this context provide a solution at the information level and at the knowledge level, which is probably the most important one. From the information level, semantic technologies enable us to integrate data from different domains and applications and facilitates the interoperability between data and tools. From the knowledge point of view, semantic technologies enable us to model the knowledge of a group of experts working on a particular problem related to energy efficiency in urban areas. How these concepts are brought into the integrated platform we have developed. You can see in this diagram, the Semanco integrated platform is made up of these 2 major components: the urban energy models, which are made of data, tools, and users that relate data and tools, and the SIF, the Semantic Energy Information Framework. This platform is the nexus between the distributed data and the tools. Just a very schematic representation of how this model works with semantic technologies. We started with the geographic information on the bottom, and on top we build layers of energy-related information. Vertically, these different layers of data are connected through the Semantic Energy Information Framework. Horizontally, there is the connection between the combined data and the integrated tools. So this means that when we applied a particular simulation tool to these models, we're going to see, because of the semantic technologies, the tool knows where is the data that is needed in order to perform a particular simulation. This is automatically done because of the semantic technologies we have developed. This is just a snapshot of the front end of the platform and how the whole process has been integrated. We have on the right side the experts' knowledge and the repositories of data. There's a big part of this project which has to do with capturing the knowledge of the experts, and that's a big part of the project I'm not going to mention here. It's all described in our website. It has to do also with the systems thinking that we have seen before in a previous presentation of the STEEP project. So for an urban energy system in a particular urban area, we can create multiple urban energy models. Every energy model means a set of data, a set of tools interacting with the data, and users working on that model. So for a particular city, we can create any number of urban energy models. Within any urban energy model, we can create plans and projects to improve the existing baseline conditions. So this is the front end of the platform, how it is as a final product. In a few weeks will be everything available in the portal. It works in real time on 3D. This is the software developed by Agency 9, the 3D visualization. It's a commercial product for the 3D visualization. Has been integrated into our platform we have developed in the project. There are 4 different visualization modes. There are urban energies, models, plans, and projects. There are indicators are the building scale or the urban scale on the right side. And these are the different visualization modes. We can see the model, we can see the buildings, we can see 4-dimensional diagrams to understand where the problem areas. I'm going to give you just a quick overview. All this presentation will be uploaded so you can see it later with more detail. The platform basically enables us to do these 3 actions: to determine the baseline of a particular urban area, to create plans and projects to improve the existing conditions, and to analyze the projects to assess which is the most suited to a particular purpose with a multi-criteria analysis tool. So this is an example of how to create an urban energy model, in this case of the city of Manresa. So we just define the urban energy model, the tools that are going to be used, the data that is available, and the users. With that, we can later on see how is the conditions at the neighborhood level, for example, and then by zooming in, we can see how are the conditions at the building level, and we can navigate through the different visualization modes in order to identify problem areas where to intervene later on. So this is how the value of the semantic technology, you can see it now in action. When you click on a building, then you see all the data coming from different data sources already at your disposal. Then when you run a tool, a simulation tool like this Ursus, which has been integrated into the platform, the data that is automatically input into the tool, it's also because of this diagram I showed before with the layers of data. Automatically the data is captured and inserted into the form to generate the simulation. The results can be seen here of the simulation. So after we have a baseline, we can create plans, and we can create inside each plan different projects in order to improve the existing conditions. This is an example, again, of Manresa City. So we can develop plans to improve the old city neighborhood, and projects. Projects means that we can decide to change the envelope, the windows, so we can decide to change the building equipment, and these are different projects that they are later evaluated. So automatically we can decide, and this is what the platform enables us, to change all the windows of those buildings selected in the previous view. This is automatically done in a batch processing, and we can evaluate later the outcome, the result of applying these changes in all the buildings automatically. So as a final stage, we can evaluate with a multi-criteria tool which of the projects is more appropriate. And this information can be given to the policymakers, to the urban planners who have to make a final decision about what actions are the most appropriate. So we have done 3 demonstration scenarios with all of these 3 processes: baseline, construction, evaluation, creation of projects, and evaluation of the multi-criteria. This process has been done in the 3 cities, has been concluded this month, and in each city has been a different scenario with different purpose, different actors, different data, different tools, but the same platform. In Spain, in Manresa, it was a non-specialist who was interacting with the tool in order to find out which of the projects were better, building envelope changes or heating system improvement. In Newcastle, we use the data from the statistics department in order to identify fuel poverty areas with the also purpose of refitting existing housing building in this case. And finally, in Copenhagen, it was just for a greenfield application in order to be used by consultants in order to evaluate projects in the North Harbour area, which is under development at the moment. At the moment, we are now going beyond the 3 case studies of the project, and we have started to develop, to implement new cities, and one of our case studies is Torino, and there are other ones who are now being implemented. And finally, I'm also announcing here in this occasion that after the project is finished this month, we will continue with a new platform called EE-Cities with the purpose of exploiting the technology and the know-how developed in the project. So you are invited to follow the further development of our activities. And if you need further information about the results of the project, everything is very well documented in the website. And if you need any other information, please don't hesitate to contact me. Thank you very much.
Thank you very much, Leandro. So we have had a very interesting 5 presentations. A global view from International Energy Agency telling us that, well, we have to focus on transport and buildings, and we are losing about 25% of energy. Very nice experiences in Bristol and Torino on projects and implementations, system thinking and open data, and matching demand with RES and planning, and as well a socioeconomic approach to assess the renovation, which was quite interesting. We have had as well a particular study on how energy storages can be deployed in order to boost or facilitate integration of renewables and to optimize energy in a district level. And finally, this very interesting tool on semantic technologies in order to really assess energy planning in districts. So it has been a very nice overview. I think it's time to open the floor to the audience in order to take any question you may have or comment. Is there any question? You have mics over there. If you want to stand up and make any question. You have to stand up and go to the, yeah. Please refer your name, institution, and to whom you are addressing the question, please.
Hello? Oh, okay. My name is Pablo Valerio. I work for UBM Future Cities in the US. One of the things that I see here is a lot of European projects. Basically, 4 of the speakers have been talking about different European projects about energy management. And one of my concerns or questions is about how are you collaborating with other regions of the world? Because, you know, during the last century, basically the West had a kind of a free ride on basically burning energy all over the place. And now countries that they are actually increasing their energy production, like, for example, places in South America or places in, you know, in Asia, are actually asking for kind of a free ride as well, but we're asking them to be green. What is the basically the collaboration going on between your projects, between your experiences with those countries?
Is anyone willing to answer this question? You have a mic over there as well.
Well, I think the central point there, correct me if I'm wrong, is that in developing nations, because the Western world or Western Europe is that far ahead in terms of energy efficiency, we have an expectation that they do the same without having the economic development already in place. I think it's a good question, but I think it's based on a fundamental misconception about energy efficiency and energy management measures, that they are somehow blockages to business and economic development. In Bristol, certainly, we try and make the point to new developers that energy efficiency measures actually form a strong business case, and we've got a big profile around resilience and making sure that when you're providing energy or using energy, it actually makes business sense and good economic sense for your buildings and for your staff, for example, to be engaging with those kinds of interventions. So I know that there's a kind of almost condescending approach to developing nations in terms of expectations around their green credentials. But I think the two aren't mutually exclusive. I think we can have certain standards around our carbon footprint, we can have certain technology and share expertise, and that actually helps to increase the economic development of a region rather than forestalling it. So I do take the point, but I think it's incumbent on especially European level projects to be able to share the expertise around how what we do has benefited communities both in an economic as well as a environmental sense.
Is anyone else willing to have a comment on that? No? Any other question? Is there any question from the audience? Yeah.
Dennis, and I study energy for smart cities. And I have a question concerning the World Energy Outlook of the Energy Agency that came out last week. I saw there that you predicted in the new policy scenario, renewables would cost about 200 euros per megawatt hour by 2020, which is about 5 times the current cost of our electricity. So do you think that it's well, should we then invest in these expensive renewables, or do you think there are more efficient ways of using our money for the environment?
I'll do the best. It works. Okay, sorry. I'll do the best of my ability to answer this question. I don't work for the World Energy Outlook team at the IEA, although we obviously are very closely tied to the modeling work that they do in my division. I think there's a couple of questions here. The first is regarding prices, and as you know, there's been a shift in the last 2 years with oil prices dropping considerably from their peak of about $140 per barrel, which has driven a lot of decisions, as has cheap coal in the renewables market. At the same time, we've also seen that a lot of governments have put out either mandates or subsidies for the development of renewables, and this has counterbalanced some of this market effect. Looking forward, I think some of the pessimism in the new policy scenario for the price of renewables is based on the expectation that over the next 5 years, there won't be significant changes in the oil price market, and this is driving some of this. At the same time, there's also a question of, is it worth then pursuing renewables under these expectations for higher costs? I think first we should distinguish between the different renewables markets. What we've seen in the solar market in particular is far beyond expectations, and I think it's fair to say that this will continue in the near future, meaning that solar in particular may be at price parity in many countries and therefore is a viable option. In others it may not. We would hope the same kind of technology cost curves would happen with other renewables markets, but I think coming back to the principal point that mandates and subsidies have largely pushed these markets, that if we really want to see the development happen across these sectors and have renewables be a viable option in the energy market, then governments will continue to have to push for them. Otherwise, low prices in oil and coal will continue to drive markets towards away from non-conventional energy uses and towards carbon-intensive forms.
Thank you. Is there any other question? Please.
Paula Kirk from OVARP, an engineering consultancy. Thank you very much. Some fantastic presentations. I was particularly interested in the energy master planning modelling. And my question is, have you had any involvement from developers or the utility companies, energy suppliers, in actually providing data or actually using any of these models?
Well, this is clearly one of the weak points and key issues of the whole story, because this data is not always easy to get. In our case, we were not able to get the consumption data from supply companies, but it's of course one of the data sets which is absolutely necessary to take decisions in this regard, as well as the energy certification, for example. Energy certificate is also something that is easier now to integrate. At least here in Catalonia, is getting in the direction of open data. But consumption it's a key issue. In our case, we could not get this data. It doesn't mean that we could not add it with the framework we have created, but it's just a matter of availability of the data.
Any other comments? No?
I just wanted to add to that. In Bristol, when we engaged in the energy master planning process, and we tried to get those sorts of utility owners and developers into a room, obviously we met against not a level of resistance, but probably a level of indifference to what we were trying to achieve. We also had the same issues as the Samanco project, where the data that we were trying to gather around energy consumption was sometimes incomplete because of our metering system, and also because the energy services companies that were providing that data were quite dubious about the purposes of providing that data. So what we've tried to do in Bristol is develop our own energy services company. So people in the room might be interested to know that when we can't go, if we're going through a particular barrier in terms of energy services and provision of that kind of data, then we're trying to do it ourselves. So that was our workaround to that kind of restriction.
So I think we have to conclude. I would ask the speakers just for a last statement, if you allow me, and linking to the initial session of the Smart City Congress. We have mentioned, out of the Barcelona mantra, I capture one word or couple of words, which was self-sufficient city. It's a big word, I would say. It's a nice vision and objective, but which would be, at your view or your point of view, main things to tackle if ever a city wants to develop and achieve this ideal objective of a self-sufficient city?
I suppose I've got a couple of points. They're more reflections than anything, and I don't want to run contrary to the general ethos of the expo itself. But in my experience, in terms of specifically energy in the UK, the main stakeholders and the main barriers are not confined within a city region. They're not confined within a city limit. So when we talk about smart cities and when we talk about the prevalence and the emerging importance of cities, we also have to be wary that we're also talking about the importance of our capital cities, our wider regions, and the interconnectivity between the two. Certainly in England, in terms of energy provision and energy services, we've got huge private sector organisations which aren't confined to localities in the way that citizens are confined to localities. So that would be my first point. My second point, off the back of the introductory session that I'm sure you're all a part of, is we talk a lot about citizen engagement and making sure that we're taking people with us. I think we have to be very careful that our rhetoric doesn't outstrip our current activity. What we tried to do with a number of projects in Bristol is actually re-empower and re-democratise the whole energy process by giving it back to individuals. So we're all here as technical experts, but what I'd also be wary of as a note of caution is making sure that whatever processes we're engaged in, we're not assuming full control. And that's my overall remark.
I think on the similar note, it's important to, as I mentioned earlier, and I think you begged this point on understanding the different actors and how complex energy systems are. And I would reframe the question perhaps, although I understand the attractiveness of resilience and self-sustainability, but reframe the outlook for energy in cities to energy efficiency as what we call the IA, the first fuel. Often when we start thinking about sustainability or self-sufficiency, resilience in the network, this essentially implies that we build lots of renewables. And we're forgetting the significant gains that can be made in energy efficiency in terms of reducing demand before having to address then how that demand is met. As a second point, I would also point out that and this comes back to your point of who are the actors involved. We should be careful in addressing this energy efficiency sustainability debate from an angled perspective in which we don't engage the different actors. I think most particularly in the buildings and transport sectors, we're talking about really getting behavior to change, the way people consume energy, whether it be for mobility, whether it be for heating their homes. These are slow processes. They do not happen overnight, particularly in the transport sector. When we talk about self-sufficiency, that begs essentially the question of, can we meet enough electricity to have electromobility in cities, because the transport sector consumes 55% of global oil, and it's not going to change overnight. So in that sense, really thinking about the energy efficiency gains frames it in a way that I think is much more manageable, much more digestible for consumers, and certainly has as much bang, if you will, for your buck than pursuing this from a supply perspective.
So regarding your question, if we can have some cities, some self-sufficient cities, in our case, we have, from our analysis, we have seen that we have some cities with a stronger potential, with a higher potential, and some other cities or municipalities with a lower potential. So I think that we have to think in a district way. We have to put together the most powerful cities and the cities with less potential if we want to attain that objective, so the self-sufficient territory. We have to think at a territorial level.
I would like to add a couple of points. First of all, as all of us know, most of the cities of the regions, if you want, have a lot of renewables in place. And coming back to one of the focal point of the project, which I before illustrated, is let's try to exploit as much as possible what is already in place. That's, according to me, one fundamental point. So I don't know if that would be something which will be bringing us or the interested cities to a 100% self-sustainability or along this novel path, but however, let's try to exploit as much as possible. This is one point. So that is something which is naturally bringing to identify technologies which are able to respond to this already carried out societal investment. This is one point. The second point is that you should not forget the extreme weather condition which we are going to deal in the recent years. I don't know, I'm not a scientist in that respect, but even the local or the self-sustainability systems, according to me, will be gaining benefits for the local communities, even to deal with unexpected or this kind of extreme weather condition to deal with. So if you are able just to local to produce or to make available energy at local level, probably that would be something which will reduce your dependencies for outside in order to deal with faraway transmission of energy. And finally, to come back to the question of the colleagues between audience, in terms of bringing expertise on of countries in development like Brazil, India, or whatever, technologies are there, and just coming back to the experience which I presented before, there are some concrete links even with cities in some kind of these countries in terms of not using the network, but in terms of selling these technologies like a microgrid. So it is something which is not far away from this kind of technologies, but the perspective is rather different. Probably Europe is completely networked. If you go to other countries, probably you need even to consider some kind of different angle, different perspective for selling best practice in a contextualized way. This is something which we are considering. This is something which, in terms of best practice, we have to take into consideration. That is not 100% copy and apply or paste, but just to take into consideration of the context, which is truly different from the European cities. Thank you.
Okay, thank you. Well, I would like to, in the context of our experience with the project Samanco, I would like to emphasize two things. One is the holistic nature of anything that has to do with energy. Has to be approached. We have mentioned systems thinking, but I think the idea that everything is related is very important, because we cannot just invest in changing windows in a whole city, and then it happens that part of the population is just traveling 40 kilometers with a car to go to work in another place. So that both things are related in terms of energy. So this is one of the problems, I think, that cannot be isolated. I mean, this is in energy systems is mentioned as the difficulty to define the boundaries of the system. Every time we think about in terms of systems, the question that arises is just where are the limits? What elements are we considering? And the second thing, in the context of this event here on the smart city issue of data and so on, I think our experience from the project, and probably something that has been repeated also by other people in the field, it's very difficult to transform information into knowledge and to be able to, with the data we have, to really make other people understand all the problematics behind by representing that data in an intelligible way. This is a very complex process, not trivial at all, and it's not only a matter of having data or not. It's also a matter of knowledge construction from the data we have, and knowledge representation, that this data is intelligible for somebody to make a decision that makes sense and has an impact on the energy system. So this issue is not trivial at all, and I think this is one of big challenges in terms of smart city thinking.
Okay, so thank you very much at all. I would like to thank again the speakers for the nice contribution, for keeping the time, for the value of the contributions. Thank you for the audience as well for being here and participating. So the session is closed. Enjoy the Congress and see you around. Thank you.